Welcome to our first online lesson. It's Mrs. Sperber here. I hope you guys are doing well at home. We miss you guys already. Hope spring break was awesome, that you had a great time. Welcome to Chapter 9. Chapter 9, the homework is a little bit more application, so if you need help on that, feel free to email me. But this is all about area, perimeters, and circumference. So we're going to be doing all of this online, and we're going to go ahead and get started. We're going to start out with areas and perimeters of triangles, parallelograms, and rectangles. Hopefully triangles is a review. A rectangle, you can see here that the area of a rectangle is just base times height. Hopefully you remember that. You take the base of something and you multiply it by the height of something. A parallelogram, kind of like a slanted rectangle, looks similar, but you just take the same formula, the base times the height. Now the height is the portion that makes a right angle with the base. So you can see it drawn in here. They sometimes call it the altitude. In this case, you can see that the height is right here. But in this one, when this is the base, it could be you kind of have to go out a little further, and this right here is actually the height of it if the base is turned sideways. Or if this line is the base, then this would be the height. So it just kind of depends on which way you're looking at it. The area of a triangle is just base times height, but then divided by 2 or multiplied by 1/2 as seen here. I think we've done some of that before. You can kind of see the picture there. So I thought we would just do some example problems and make sure we are familiar with that or recall that. Triangle and rectangle have been done before, but I think parallelogram is new. So find the area of each parallelogram. This one has a base of 14 and a height of 3. So all we have to do is say the area is equal to 14 times 3. I'm going to grab my calculator out. I don't have my drawer of calculators for you guys. But I did 14 times 3 and I got 42. Just be careful to note that the units here are feet squared. On this one, I have kind of 4 choices for you. Is the area 80 inches squared, 90 inches squared, 80 inches, or 90 inches? I'm going to go through and kind of cross off ones that it's not. It cannot be 80 inches or 90 inches because the units aren't correct. Area would be in inches squared. So I'm down to A and B. The base in this case is 10, and the height, I couldn't tell if it was 8 or 9. And if we look, the 9 is slanted, but the 8 is makes a right angle with the base. So it would be 10 times 8, and that would give us A for our answer, 80 inches squared. If we keep going, this one wants us to work backwards a little bit. They're like, okay, well, if this is the base of 8, and this is a height of 3, I can easily find the area to be 8 times 3 is 24. But then they were like, what if I turned it sideways? And the 4 right here was the base, and they wanted to know what this height was. So my area is still the same here. The area is 24. But this time my base is 4, and we don't know my height. We just know that the area in general would equal that. So 4 times the height, as shown right here, would equal the area, which is 24. So if I divide both sides by 4, I can get that height to be 6, and they didn't give us any units, so maybe inches or feet or something like that. So that's kind of working backwards a little bit. We can practice one together here. If I look at the shape this way, with that being the base, I could say that the height is 4, and I do 3.8 times 4, and the area would be 15.2 is the area. But if I re-looked at this shape sideways and this was my base, then my area would be 9.5 times the height. And again, it would still have to equal 15.2. So if 9.5 times h was 15.2, if I divide both sides by 9.5, then I'm gonna get 1.6. So the height really depends on which way you're looking at it. The base could be 3.8 and the height 4, or the base could be 9.5 and the height 1.6. So just looking at some of these shapes we know in a little bit different of a way. Let's review area of a triangle. Hopefully remember this. A lot of people just forget that 0.5 or that 1/2. So area is 1/2 times base times height, or if you want decimals, 0.5 times base times height. So my base here is 11 and my height is 3. So I'll say the area is 1/2 times 11 times 3. You can multiply these two together first, or if you just want to type all three of them in your calculator, that's fine. So 1/2 times 11 is 5.5, and I multiply that by 3. 1/2 times, and I got 16.5. And again, the area is in inches squared. So same thing over here. This time, if you'd like, you can do two separate triangles, the green one and the pink one. Ooh, my two favorite colors. Or you can look at it as one entire whole triangle. So, like I'm drawing in blue. So I'm gonna go ahead and do it the whole thing. So the area, the base would be 5 plus 8, which is 13. And the height is 6. And boom, don't forget your 1/2, which I almost did. Multiply that out, and 1/2 times 13 is 7.5 times 6. Nope, I lied. It's 6.5 times 6. 1/2 times 13 is 6.5 times 6, and that gives you 39 units, again, feet squared. So far so good, hopefully. I'm not there to ask. But next we're gonna look at a scale drawing. This is an obviously tiny house. This is very realistically not 20 feet because it's on my iPad, and it is not 20 feet. But what they're saying is it represents 20 feet, and they wanna know, we're going back to a couple chapters ago, the scaling. So every 1 inch represents 20 feet. So you can convert to inches in the beginning, or you can convert at the end. I'm gonna go ahead, it says a scale drawing of the side view of a house is shown on the right. Find the total area in square inches of the side of the house in the drawing. So again, real life versus the drawing. I'm gonna go ahead and convert in the beginning. So here, 1 inch represents 20 feet. So I'm going to look at a couple different things. This green one is 20 feet. So I can kind of right away know that is going to be 1 inch on the drawing. 1 inch to 20 feet. The other ones aren't as easy. We can see this purple one. 1 inch is 20 feet. So 24 feet would be equal to X inches. And I can cross multiply. I get 20x equals 24, divide by 20, and that should be 1.2 inches. So this will be 1.2 inches on the drawing. And then my last one is this red, this 8 feet, and my 1 inch per 20 feet. I'm going to have to look at what that would be for the 8 feet. what would that be in inches? I'm not converting to inches, I'm just scaling it. So what would it be on paper? So crisscross applesauce, that's what my mom used to say. And we have 20x equals 8. Divide both sides by 20, and we will get 0.4 inches. And so that's how tall this is on the picture, 0.4 inches. We're not even done. Such a long problem. They are saying to find the total area of the side of the house in the drawing. So I've got two shapes here. This beautiful pink square right here, rectangle, sorry. If I shade that in, I know you wanted to see me color on your work from home day. This one will be the base of it times the height of it. So the base here is 1 inch. And the height is 1.2 inches. And that should give you an area, this pink, of 1.2 inches squared. So that is the area of the pink box. Now we're gonna look at the roof of this guy. Let's pick orange. And in orange, this orange triangle in here, we have to find the area of a triangle. So we have 1/2 times the base, which it doesn't show the base on the triangle, but I can see from below that it is also 1 inch from down here. That 20 feet is 1 inch. So 1/2 times 1 inch times the height, which is 0.4 inches, and that will multiply to be 0.2. And again, inches squared. So we have 0.2 inches squared for the orange section, together giving it a total of 1.2 inches squared plus 0.2 inches squared, which will give us 1.4 inches squared. And so that's the area on the paper. Not the area, obviously, of the real house, but the area of the scale drawing. We're going to go into combining some shapes. So there are only 2 problems left. Oh, this is such a short time I get with you. I want to hear more about your lives. Hopefully you're enjoying being at home. Come back soon. Not too soon, though. We want to make sure we're all safe. But there's a couple ways you can do this. You can look at this as a square that has this shape cut out of it. Or you can look at it as just 2 triangles that you got to add together. So I'm going to go ahead and do the 2 triangle version. I got my purple triangle and my pinkish triangle. I'm just going to find each of those areas and add them together. So for purple, I have, actually, I don't really know how long each of these is. So what I'm going to do instead is I'm going to do my first method, because I can't really tell how long is that X and how long is that Y. So I'm glad I kind of ran into that. Sometimes you can cut it into 2 pieces, but I don't really know the bases of those. So instead I'm going to look at it at this big blue square right there, and I'm going to cut this orange part out of it. So the big blue square is going to be base times height, or 14 times 14, which is 196. So that's the area of the big blue square. And then the orange one I need to find the area of. So I know this height is 14 feet, just because it's a square, so top and bottom are the same. And then the height of this triangle is also 14 feet. That is because, That is because this is 14 feet. So the area of a triangle is 1/2 times base times height, which gives you 98 feet squared. So if I want to know the purple and the pink, what these areas are together, then I'm going to take the blue square and I'm going to subtract the orange triangle right here. So we'll do the 196, and I'm going to subtract the 98 feet squared, and that will give me 98. So the purple and the maroon, or the pink, together are 98 feet squared. Now, are they each 49 each? Probably not. It looks like the purple one's the bigger, but we can't really say exactly. So there you have it on that one. Ooh, this one's cool. Couple options. You could say, oh, it looks like this is a triangle, and this is a trapezoid. I could do that. I don't really know how tall the portion of the triangle is, so I'm gonna ixnay that. I'm not gonna do that way. That could work, but this looks a lot easier. If I have this gray shape rectangle, and then this orange triangle. And I do know how tall and how the base is for the rectangle. So I'm going to go ahead and do base, which is, well, the base is 5, the height is 16, multiply that, and I get 80 meters squared. Now, the orange triangle, they don't really tell me how tall this section is right here, but I can do 16 minus 6.5, which is 9.5. I did that in my head. Are you proud of me? And I know the height now because this 6.5 is what I subtracted out. The base is not 14. It is 14 minus 5 because I know this section right here is 5. So 14 minus 5 is 9. Did that in my head again. Look at me go. And that is 1/2, I almost forgot that, 1/2 of 9 times 9.5, and not doing this one in my head, that is 42.75 meters squared. Then no subtracting here because we are taking the gray and the orange. We're going to add them together, and our total area is 122.75 meters squared. I think this is practical if you're trying to lay floor on a house, which I probably need to do sometime soon. If you're trying to find the area for a dance floor. One of my friends put together the dance floor for their wedding. They got pieces and they were figuring the square footage and how many people were on this. So I do think this section's pretty practical. We're going to be finding areas of things, perimeters, how far it takes to walk around something, how much paint you need to fill something up or to paint over it, or carpeting for a house, things like that. We're going to start going 3D in a couple of lessons. Probably not just quite yet, but that's kind of where we're headed towards. But we're going to stick two-dimensional for right now. So the homework for tonight is right here. There are a lot of application problems. The homework has some special right triangles in it when we had those 30, 60, 90 triangles, things like that. So do your best with these, and good luck. I will talk to you tomorrow.